It is very fitting that we're sitting here in a Whole Foods restaurant that embodies these philosophies around food as medicine, because what you'll notice as a theme through the course of this discussion is that food plays a really important role in determining our health, and that, so there is this really important parallel. And I think it's funny, as I was sitting here listening to this introduction and looking at the title, is that we're seeing something married here that isn't necessarily married in our healthcare system, and that is the relationship between nutrition and what is perceived as a irretractable chronic disease with no known cause. So what I'm going to do is not give you any answers. I don't propose to have any answers. I don't know everything. I don't claim that I do. But I know a little bit about chronic fatigue. I've done a bit of work in this area, and I want to share with you some of the, not even solutions so much, but more ideas and concepts that are emerging around this field that are helping us understand it potentially a bit better, explore it more as through a different lens or a different view of looking at chronic fatigue in a way that has the potential to help people better than what we're helping them right now. Because one of the problems with chronic fatigue, for anyone who's worked in this area or experienced it themselves, is we're at a bit of a sort of a roadblock in terms of our treatment. So the gold standard treatment for chronic fatigue in the UK is essentially, if you're diagnosed, it's a diagnosis by exclusion. It takes a very long time to actually be diagnosed, and if you are lucky enough to fall into this definition and then be identified as someone suffering from chronic fatigue, you're lucky enough to receive the gold standard treatment. I will be a bit opinionated about some of these things because they're just not really helping people very much. So the gold standards are cognitive behavioural therapy and graded exercise therapy, which don't resolve the condition. At best, they result in modest improvements. At worst, they make people feel worse as well. There are no approved drugs for chronic fatigue. There are no clear treatments that people can receive that they'll respond very well to. So it is a very frustrating condition for those people who are experiencing it, their family, their loved ones, the burden it has on our society and the healthcare system. It also, for me, is a little bit of a personal story as well. It's funny, a lot of the areas that I've ended up in, although they're quite diverse, have been for personal reasons. And one of the reasons I've done a bit of work in this area of chronic fatigue is because I experienced it as a teenager. So I was bedridden for several months, went through the standard experience that a lot of people experience of going to several doctors, not getting a lot of answers, maybe getting some positive blood tests, but there's nothing we can do about it. But for me, a tipping point or the thing that really changed my experience of fatigue was seeing someone who thought a bit differently and started working with my diet amongst other things. And I responded very quickly. And for me, coming out of fatigue that was so frustrating, like there was no hope for so long, and doing it through something so seemingly simple. I had no idea that diet could have such an impact on our health at the time. Amongst other things, I should say, more personalised nutrition was a big part of it. For me, it was pivotal in really shaping where I was going to go with further education and other areas in my life later on, whether I knew it or not at the time. So, subsequently, part of what I've been doing in this broad field that I work in is trying to help raise awareness about some of the potential ways we can help people with chronic fatigue. And that's what I'm going to do tonight, is just take you on a little bit of a journey into that area. It is a very complex topic, and I am going to speak more conceptually than I am dive into a lot of detail. But just come with me on the journey. And I also realise that some people are health professionals in here and some are not. So I may lose some of you and I may bore some of you at some point, but again, just come with me on the journey and we'll see where it all goes. So before I get started, I just want to make a few personal disclosures. I have educational responsibilities and affiliations. No one really cares about that, but I do have commercial links that I should disclose. So I am a consultant to a company called Pure Encapsulations that make herbs, vitamins, and other things that I'll be talking about. So I need to put that out on the table. But apart from that, the talk is my own, the work is my own, but just so you know. All of the notes, as been mentioned, will go out to you in an email, and I'm more than happy to share any of this for free, obviously. I have contact details there if you want as well. Anyway, I'm not here to talk about me, I'm here to talk about chronic fatigue. And what we're looking at with chronic fatigue is basically a multifactorial illness, meaning there are multiple causes that vary from person to person with a high degree of heterogeneity in the disease pathophysiology. So what I'm saying is that there are multiple causes, so it's multifactorial, and there's a high degree of heterogeneity in the pathophysiology, which means that there's lots of different things going on in the biology of people with chronic fatigue that vary from person to person. So you're starting to see a picture emerge here. This is not a simple disease with a simple clear-cut cause or a simple clear-cut solution. It's complicated and varies. And that is kind of the key message that I want to give you as we move through the next hour or so, is that it's complex. We don't have all the solutions. And a big part of understanding chronic fatigue is understanding that it is complicated. And we'll expand on that. So as Professor Stephen Holgate points out, who's a researcher who's been involved in the area of chronic fatigue for several years, is that to call chronic fatigue or myalgic encephalomyelitis, it has different names. I'll interchangeably use CFS-ME as terms. To call it a single disease entity, as he says, greatly undermines or underestimates the complexity of the problem. It's not a single disease. It has many different shapes and forms that vary from person to person. Now, this is great for people who practice functional medicine, because this is exactly what we love working with, is complex disorders that vary from person to person, because that's exactly the lens through which we look at human health and disease. It's horrible. It's absolutely horrible if you're conventionally medically trained and you're used to identifying diseases based on a diagnostic criteria and prescribing an appropriate treatment, largely pharmacotherapy. It just doesn't fit the model. It doesn't fit that model at all. But it fits functional medicine. And I'm going to expand a little bit on what functional medicine is, how it operates, and how we can use that model to help better understand a patient or someone with chronic fatigue. So as Jeffrey Bland, my friend and past colleague, and the founder and father of functional medicine, says, is that what we're concerned with is in functional medicine is not really understanding a disease at all. We're moving away from that. We're moving away from this sort of naming and blaming to understanding an individual, understanding their function. That's what the function in functional medicine means, is we're looking at function. And that's going to vary from person to person. And it's not necessarily related to a particular disease name. It's understanding an individual's physiology. So if we start applying this thinking to chronic fatigue, we start to look at it a little bit differently. It's not, oh, you have chronic fatigue. It's, oh, I need to try and understand what's going on here. And that's what I did with a relatively recent paper. It's got a few years on it now. This is published in Alternative Therapies in Health and Medicine back in 2014. And what I did at the time is just what we call a narrative literature review. I'm not a high-tier scientist. I don't do things like meta-analysis. In fact, I don't want to. But I have done a few of these kinds of studies. And what I did with this is sat down and went, well, we need to pull together some of the things that people within the functional medicine and nutritional medicine community are doing, pull it into a working model, synthesize it a bit and get it out there in the medical literature so people can see it. And that's kind of what I did, is I sat down, looked at it fairly rigorously, pulled it together in a narrative review, formed a construct based on this integrative functional type view, and luckily for me, it was accepted, went through peer review and was published. But really the purpose of this review is to help us as clinicians clutch onto the science that helps us unravel the disease, basically. That's all it is. And I'm going to use the framework that I proposed in this paper as a model for where we're going. I don't have time to talk through the 100, 200 or so references that I used, and then the hundreds more that I didn't use that are in there. But I'm going to talk at a sort of top level, pick out a few interesting examples and throw in a little bit more that we've learned since this was published as well. But the model here is quite simple. It's, well, I say that, it's not especially simple, but what I focused on was this idea that there are modifiable physiological and environmental and nutritional factors that we can address in chronic fatigue that are likely to be not only contributing to symptoms, but will help us unravel it and result in improvement in symptoms as well. What I'm concerned about when I'm talking about unraveling disease often is not really what's causing it, because often the horse has left the stable. I don't know if that's the right analogy, but you kind of get what I mean, right? There's often when we're talking about causes of disease, it's too late to bother with the cause. It's gone. What we really need to be thinking about as clinicians, or for the clinicians in the room, is how do I rehabilitate this person? You know, forget that a viral infection 20 years ago was a trigger. That's gone. What you have now is a person in front of you who needs essentially rehabilitating, understanding their function, improving their function and getting them better. So that's what I was focusing on, is like what's going on in their function and their diet, lifestyle and environment, and explored a few sort of key areas including nutritional considerations, physical fitness, psychological and physical stress, environmental toxicity, gastrointestinal involvement, which is interesting, an area that's exploded since I published this. It's fascinating. Certainly immune dysfunction has been well established for many years, inflammation, oxidative stress and mitochondrial dysfunction, which, you know, they sort of sit on the periphery. That's really just a way of conceptualizing it. We might need a tissue. You need a tissue? Yeah, just a spilt drink. It's going to be that kind of party. We'll order wine halfway through. But mitochondrial dysfunction sort of sits, these look like linear relationships that sort of sit neatly on the outside, but they're all interconnected in sort of a web-like pattern. And mitochondrial dysfunction, I'm going to focus on it with a bit of emphasis because it sort of sits at the core of all of this, in this, if you start viewing it as a web. And it's fun to talk about as well. So I'll talk a little bit about that. So we're going to step through most of these to some degree and touch on some reasons why they're relevant. We'll explore research related specifically to chronic fatigue and draw on research outside of that sphere that's relevant as well. And I'm going to focus largely on news to use. So although we'll be talking about a lot of science, I'll focus mostly on clinical studies where we've seen you know, potentially important clinical outcomes rather than just biology and biochemical pathways and things. But I will start with a biochemical pathway. So for those of you who studied biochemistry, or this is probably scaring you right now because you would have like rigorously studied this for several months and then gone through exams, and you'd be so sick of the Krebs cycle and the citric acid cycle that it just kills you and brings back these memories. But it's cool, and we should revisit it. And science has moved on a little bit. It's not that, you know, we've got these lovely, we didn't have these color diagrams when I was doing biochemistry. We had these like boring flat pathways. So we've got these lovely images, and we've also got medical imaging and videos and stuff now to really bring it to life. And that's what I'm going to show you in a minute, is a video to bring the mitochondria to life. And the reason I'm talking about these things here, these are the mitochondria for those of you who have not seen them before. They're small little organelles that sit inside your cells. So they're actually so small, they're inside your cells and they're moving around dynamically producing energy. That's what they do. They're the energy producing parts of your cells. So these mitochondria, as the energy producers of our body, are kind of like the Force in Star Wars. They're kind of like the Qi in traditional Chinese medicine. They're the substance within our body that gives us this sort of spark of life, quite literally and figuratively. Now, understanding that, it makes sense then that they would probably play a pretty important role in the development of fatigue, and it turns out that yes, pretty reproducibly when you look at studies in individuals with fatigue, in particular chronic fatigue and chronic fatigue syndrome, is that you find evidence biochemically, biologically, of mitochondrial dysfunction. It's a pretty reproducible physiological feature of fatigue. So we know that there's something going on there. Now the relevance of that for us is we can do stuff about that. I'm going to come back to that later, but I'm going to take you deeper into the mitochondria for now. I'll just leave. You can do the sound thing from there.
Try.
We're living in the future. Just let me know when you're good.
Here we go.
Cool.
Fingers crossed.
No. I'm going to write down. So write down because I'm going to talk over it a bit. So what we're looking at here, it's a short video, is the mitochondria themselves. So this is the mitochondria moving across protein tendrils within inside the cell. It's like they have intelligence. They move dynamically to where there are energy deficits. How cool is that? What we're looking at here is essentially food moving through the outer membrane of the mitochondria into the inner membrane, and then through the inner membrane inside the mitochondria to what we call the matrix. Now the matrix is a soup of enzymes that are floating around inside the mitochondria involved in energy production and synthesis. On the surface of the inner membrane of the mitochondria you have the electron transport chain, which is what you're viewing here. These are electrons being transported across the chain that are involved ultimately in the synthesis and production of ATP. It's the currency of energy within the body. Interestingly, on the surface of this membrane you have a pump, and it's called ATPase. It's fueled by this flux of electrons inside and outside of the mitochondrial membrane, and you can see it turning here and producing ATP, which is lit up like little light bulbs here. That's the currency of energy in your body. This is happening in every cell throughout your body, including your brain right now, keeping you alive, and it literally is the spark of life. How beautiful is that? I love modern medicine and what we can visualize now with imagery like this. It's just beautiful. So at the core of all this, we have these things called the mitochondria. They produce energy. Their dysfunction is involved in the development and experience of fatigue. Now, Dr. Garth Nicholson, who interestingly, as a side fact, was involved in the original mapping and mapping of the structure of the mitochondrial membrane itself, has since turned his work in recent decades since to understanding the role of nutrition in the function of the mitochondria, and in fact has gone on to start conducting clinical trials of what are termed, or what was termed by Bruce Ames and his colleagues, mitochondrial nutrients. And we know that mitochondrial dysfunction is relevant to fatigue. We know that nutrients can influence mitochondrial function, so you can start to see the connection here. So these so-called mitochondrial nutrients are nutrients present in our diet. They are largely vitamins, minerals, but they may more broadly encompass phytochemicals, we're starting to realize now. But these nutrients generally fit three criteria. They're able to enter the cells of the mitochondria following exogenous administration, that means eating. Two, they protect the mitochondria from oxidative stress and damage. So most of the oxidative stress in your body is happening in the furnace that is your mitochondria daily. That's normal, but it can be excessive and we need to be protected from that. So the nutrients, so-called mitochondrial nutrients, play a role there. And thirdly, they have, or as a prerequisite, need to be shown to be able to improve mitochondrial function. Now, question you're probably asking already, I'll come back to this, is what are the mitochondrial nutrients? Well, it turns out it's just about everything. So it's most vitamins and minerals literally fill this criteria. As part of cellular energy metabolism, we utilize loads of different vitamins and minerals. I'll show you what they are in a moment. But what I wanted to do for now is just set that scene, is that we have fatigue, and at a cellular level, the mitochondria are playing a core role. But stepping out of that for a second, it's really important, I think, in all things in life, especially medicine, not to get too fixated on any one thing, and to start, and always to put things into perspective. The mitochondria sit inside your cells. So the function of your cell determines the function of your mitochondria. Your cells sit inside your body, and your body sits inside an environment, both a social environment, a food environment, and a planetary environment. And they're all interconnected. So you don't want to get too hung up on one thing, because it's all part of a giant web and it's all interdependent on each other. And as Dr. Alex Vasquez says, is that when you're looking at mitochondrial disorders, you always need to keep that in perspective. You need to ask, well, what is causing the mitochondrial dysfunction? Not just pump people full of mitochondrial nutrients or focus really specifically on that. It's, well, why are they dysfunctional in the first place? It could be many other things outside of the mitochondria, outside of the cell, in the environment. It could be food. It could be nutritional deficiencies, it could be exposure to environmental pollutants, as we'll see. There's all sorts of things that could be fundamentally affecting this internal process. So what I'm going to do is take you on a very top level, almost superficial journey through chronic fatigue, looking at some of the dietary, environmental and lifestyle factors. We're largely going to focus on nutrition just because we're here. But also because it's very relevant. We'll look at diet, we'll look at nutritional status, we'll touch on some of the other areas, and hopefully you'll get something useful out of all of this. So we'll start with food. Now, tragically, there have been no clinical studies ever done on dietary interventions in people with fatigue that I'm aware of. How crazy is that? To give you an idea on how lacking we are on dietary studies for anything, the first study of a dietary intervention for depression was only done 2 years ago. 2 years. How insane is that? Guess what? 40% of people went into remission within 8 weeks. Remission. With an antidepressant drug, you're lucky if 40% of people respond with a 50% response rate. So this is like, diet's powerful. No one's ever tested it in chronic fatigue, it's crazy. But we have a little bit of evidence from other areas to suggest that it would potentially be very useful. So I think logically it makes truckloads of sense. I've seen it help people, other people have seen it help people, that's just anecdote, but we also have evidence from other areas to suggest it would be useful. A study I've been referencing for years is this one by Andrew Scully and colleagues. It was done back in 2011. It was cool because it was one of the first studies where they're just looking at positive effects of eating well in people, like effects on vitality and energy and vigor, and they just gave people a simple traditional Mediterranean style diet. So that's loads of fruits and vegetables, no junk food, all the good stuff basically is what a traditional Mediterranean diet doesn't actually exist. It's just a construct that was developed by a group at Harvard to get people eating well because they thought Americans would love the idea of eating a Mediterranean diet. Weird, but what it actually is a model for healthy eating based on a few criteria. That's essentially what it is. We use the name, but it's just the name. So they gave them this very healthy dietary approach. Within 10 days, they saw measurable improvements in mood, mental vigor, energy, well-being, and since then we've seen some pretty powerful effects, as I just mentioned, in areas like depression. And then if we look more broadly at studies of the traditional Mediterranean diet on parameters relevant to chronic fatigue, which is what I had to do for my study because they just don't exist. So I'm sort of clutching at, loose ends a little bit here, but we know for sure from human clinical interventions that if you eat this way, your mood improves, your depression becomes mitigated, you can reduce anxiety, you can reduce some of the physiological features we see in chronic fatigue, like chronic low-grade inflammation, oxidative stress, and we also see improvements in physical fitness and performance. And as you probably know, people with chronic fatigue essentially have an exercise intolerance as part of the condition. It's a hallmark feature. So food can help. It really can, and there is some evidence to support this, although we don't have robust trials in these patients just yet, but there are groups working on this. So a good question then is, and just to indulge our passion for food for a moment, a good question to ask then is, well, how could food improve energy and well-being? And it turns out that plants are speaking to us. I don't know if you have heard of this concept. It's a little bit complicated, but I'll walk you through it. There was this concept that came out in about, actually it was a little bit earlier than this, I think in the late 90s, by Dr. Lee. I can't remember the exact publication. They came up with this idea of xenohormesis. Crazy idea. Let me explain it through the lens of red wine, because I know some of you like red wine. Saw a few smiles then. But basically anyone who knows, who likes red wine knows that wine comes from stress, the best wine comes from stressed grapes, right? So it comes from grapes that are exposed to extremes of temperature, frost, heat, drought, grown in rocks, really old, that kind of stuff, organic. And the reason for that is because environmental stress triggers the release of phytochemicals in these plants. And they're the flavor molecules. But for the plants, they're not concerned about, they don't really want us drinking them, or they might, if you ask Michael Pollan. That's the reason why some plants are cultivated. If you think about it, corn is one of the most successful plants on the planet because it likes to be eaten. Anyway, that's a whole other thing. So they're not really thinking about us eating them. What they're thinking about is their own survival. They're not producing these phytochemicals for flavor, they're producing to protect them against the stress. So the phytochemicals help protect them against UV radiation, it improves the metabolism of the plant under drought, and protects them against frost, so it improves cold and heat resistance, for example. That's why these chemicals are being produced. It's a survival response, so stress triggers a response that improves survival. Now what's really fascinating is that we can hijack those messages. So when we drink wine, stressed wine, we absorb those phytochemicals into our biology, and that triggers a cellular response in us that is a mirror of the plant in its environment. Quite literally, phytochemicals in plants trigger mild cellular stress responses in humans. Think about this for a little second right now. I mean, this sounds a little bit esoteric, but what I'm telling you is that you're connected to the plants you're eating in a way that you're interpreting environmental cues that they're experiencing. Isn't that weird? Strong argument for organic, seasonal, and other things, but we'll get back to that. But the point is that it triggers a mild cellular stress response. Now, one of the responses is improvement in mitochondrial function, amongst others, because that helps improve our metabolism, adaptation to stress, basically environmental stress. Now, that's what you're seeing here is a sort of depiction of this concept, which is since the initial hypothesis now has sort of been grounded in some pretty good and really fascinating experimental studies. So we have stress triggers the release of chemicals in plants, we absorb these chemicals into the cell, and then this sort of triggers a response in us. So there's adversity, molecule synthesis in plants, increased survival. We transfer this across species, we hijack those messages, and we respond. It also makes sense if you think about it, right? If a plant that in an environment traditionally we would have been living in as well, it's sort of communicating to us, and us hijacking that signal is a survival, it's going to help us adapt to those environmental conditions as well. But the interesting thing is, I'm not making all this up, is that we can measure these cellular responses in humans. So for example, if you feed people broccoli, which is exactly what they did in this study, and then start to measure things like anti-inflammatory responses, antioxidant defenses, and improved mitochondrial function, you can see it. So it's measurable. These plants are communicating this message and triggering physiological responses in our body that are improving our metabolism, defenses, energy production, that kind of thing. The same is true of another compound called resveratrol. They gave fairly high doses here. It'd be hard to achieve this with berries alone, but just as a case in point, this compound is present in, funnily enough, the red wine I mentioned, but you don't have to drink wine to benefit. You can just eat berries, tea, cocoa, all these kinds of things. And these polyphenols, including resveratrol, in this study were shown to improve mitochondrial function. Here I realized as I was preparing, just quickly reviewing my notes, as I got this completely wrong. I've got the wrong paper here, and the study was actually on chocolate, so it's not tea, and so it's all mixed up. But basically, the reference is right and the excerpt is right. That's about it. And what they did is they gave a group of individuals dark chocolate corresponding to about 100 milligrams of polyphenols in this case, which is, I think from memory, it's about a quarter of a 100-gram block of chocolate at around 70%, so it's not a huge amount per day for 3 days. Cool experiment to be involved in. And then they measured all sorts of measures, including a mitochondrial function, and found improvements in that. So that's all really interesting experimentally, but would this translate to improvements in fatigue? We don't really know, but we think it does. For example, this is one of the few studies where they did actually test that. They gave people with chronic fatigue chocolate. It wasn't just any chocolate, it was a very high polyphenol dark chocolate extract. They were given it 3 times a day, 15 grams, and their fatigue significantly improved. Their exercise levels had increased. They also had improvements, or reductions I should say, in anxiety and depression as well, with something as simple as a polyphenol-rich chocolate extract. Now I want to make it clear, this is not advice to eat lots of chocolate. I think what this tells us is that it's quite likely that polyphenol-rich foods, which are not just chocolate but also berries, nuts, seeds, apples, citrus, they're the superfoods. Forget, there's some exotic, expensive ones in health shops, but apples, citrus, nuts, seeds, red onions, and fresh seasonal fruits and vegetables, they're the superfoods. They're all rich in polyphenols, and it's quite likely that, similar to cocoa, they would be contributing, as a dietary source to these and improving our physiological function. Certainly, we're seeing that, and it's likely to benefit fatigue. Now, it's not just what you eat, it's what you're not eating as well. And there's been a lot of talk in recent years about caloric excess. We know it contributes to the obesity epidemic, but we're starting to become more refined about that and beginning to understand that actually there are a lot of other benefits to moderating your calories and sometimes creating a mild deficit. Now, this is very analogous to this kind of plant stress I mentioned earlier. It's normal for humans to go through periods of food scarcity. It's also normal for us not to eat 10 times a day as well. This is a fairly unique modern phenomenon. I've been trying to trace human eating behaviors historically for some time. I became very interested in the Paleolithic concept when I first found out about it in the 90s with reading Stanley Boyd Eaton and Lauren Cordain's work, the seminal work in the New England Journal of Medicine, and it's brilliant stuff. I was like, oh my God, I'm going paleo. Don't think that now, but it's absolutely fascinating. And it turns out that hunter-gatherers tend to have roughly one larger meal in the day, the rest of it they graze lightly. So when did that change? When did we go from 1 meal a day? By the way, I've tried that, it's very difficult to do. Eat all your calories in one sitting stuff. It doesn't really work with the modern human and modern environment. But when did that change? Well, a big factor was the Industrial Revolution. We went from, in Victorian times, in England, it's fascinating because we have wonderful records in England of cultural behaviours, medical records and eating. We had some remarkable historical studies. But what they know about the early Victorians is that they were eating a larger, it was a small breakfast if you were hungry, optional. There was a sort of afternoon meal which was called dinner, and if you were still hungry later in the evening you'd have a snack basically. So it was not too far off the Paleolithic concept of 1 meal a day, with a few lighter ones either side of it. So when did this change into regimented 3 times a day? Likely the Industrial Revolution, it seems. And when did we start saying you should always snack in between? I can't work it out, but I think the Milky Bar has a lot to do with it. It's a crazy idea, but it seems to me that advertising for Milky Bars, do you remember that? Not too heavy, not too light. They wedged a meal that wasn't a meal in between. So we started snacking, and then all of a sudden it's, I don't know if that's true, but the point is that we're eating very frequently, and a lot of scientists are questioning this now, and we're beginning to see that these practices you would have heard of, they've made it into popular culture as like the, periodic fasting, the 5-2 diet, intermittent fasting. These kinds of concepts are emerging because we're starting to see good science behind them as well. And the idea is quite simply that not eating gives you a wonderful period of lack of stress on your physiology, and also promotes biological responses that have net health benefits as well. Now, I'm not saying starve yourself. I think that's a really bad idea. And I don't think everyone should do the 5-2 diet either. It's about finding what's right for you, ideally working with a nutritionist to help you, find that space. And I think everyone's different. Not everyone should be doing this, but some people really benefit, and it's definitely food for thought. One of the fundamental reasons we've thought for a long time that mild caloric deficits benefit human health and longevity is because of its effects on mitochondrial function. Unfortunately, there have been very few studies examining mitochondrial function with this kind of dietary approach, but the first to ever do it was this one that I'm aware of, where they did induce just a mild energy deficit, and they found measurable improvements in mitochondrial function. Studies since then have been mixed, but this was a good indicator that that could be part of the reason this is benefiting people. Another thing we need to be asking is, well, could sugar be to blame? We know, all of us as kids know that sugar rots your teeth. We now know that it's no good for your cardiovascular system, probably real bad for development of diabetes. If you're up on the literature, you also know that sugar rots your brain as well. So it's sort of, it's becoming the antithesis of healthy nutrition right now, and for good reason. And we also know that sugar could be contributing to poor energy levels as well. For example, this study, which was a bit out of regular context, but they fed them a very high fructose or sugar diet, and they found that that was able to significantly impact the genes that are involved in mitochondrial function, thus mitochondrial function itself, reducing cellular energy metabolism. Now, that's suggesting that perhaps this overexposure to refined sugar that we have in our food environment could be contributing, at least for some people, to metabolic changes that contribute to energy deficits. And lastly, a thing that I really think deserves a lot more attention than it ever gets in nutrition, in society, and in environmental health is this issue of pesticides and herbicides that are being used on our food supply. Now, it's a fact that if you walk out and buy some groceries that are non-organic, I think we need to change our terminology as well. It's not conventional, never really was. Organic's the conventional, we've just lost track of that. So I like to call it non-organic. And if you go out and you buy non-organic food, you can measure multiple pesticides and herbicides across that food. Now, we thought for many years, or we've been told, not all of us have thought this, is that because the levels are so low there, it's unlikely to be a threat to human health. Don't worry about it. But that's really turning on its head, and if you ask any toxicologist, they won't tell you the dose is in the poison. It doesn't work like that in toxicology. Low doses of things can have very big effects. And we also know that these chemicals are working in complex mixtures as well, in ways that are unknown to us. So there is a lot of alarm around the use and exposure of these now. If you go into the toxicology literature, unfortunately this is just not making it into the mainstream. I feel like organics is still a niche. It's just not where it should be. And I think part of the reason for that is you can't see any of this. It's really hard to measure in your biology, and it's not like a hamburger that sits there and looks back at you. The pesticides on your salad, you can't see them, and the salad looks healthy. So I think it's going a little bit under the radar. And the reason I want to talk about this is because we've known for many years that exposure to pesticides and herbicides can cause chronic fatigue. It's a fact. Back in 1997, there was a group in Australia where I'm originally from that were looking at this. They were running a hospital specialising in chronic fatigue, assessing their patients, because they were getting loads of agricultural workers coming in with a diagnosis of chronic fatigue syndrome. No one knew why. Test their blood, pesticides, herbicides through the roof. They were detoxing them, which is a bit of a freaky out there term, isn't it? But they were detoxing them back in the early 90s. With, in fact, they invented a lot of the concepts that we use in detoxification today through their own experiences, and getting excellent results. And there are multiple studies since then. I summarised several in this paper if you want the cross-references, and I've given you all a free copy of this, but there are several now linking pesticide and herbicide exposure to the development of chronic fatigue. It's just how it is. So a question we need to ask is, well, why are pesticides doing this? We've been told if I spray Roundup on my lawn, it's pretty safe, it just kills grass, not humans. Why is that? Well, the reason is that's just fundamentally wrong. Roundup, which was thought to be the most harmless of all the pesticides, is now well known to affect human health and affect physiological function. It was never benign in the way that we were told it was. And part of the reason for this, and this is not the only reason, but it's a really interesting one, is that we share similarities with plants. This is a reoccurring theme, right, is that all life on Earth is connected. We all come from the same place as well, and we actually share biology with plants, or similarities in our biology. Isn't that fascinating? Now, one of the most remarkable things is this similarity between our mitochondria, which I've just shown you images of, and chloroplasts, right? So that's the energy-producing organelle in a plant. I'll show you how similar they are. That's a chloroplast, that's a mitochondria. If I coloured them differently, you wouldn't know. They look pretty similar. So they have two outer membranes, they're involved in energy synthesis. This one makes ATP, this one makes chlorophyll. That's the difference, but that's sort of the plant's currency of energy. Now what's interesting, because of these structural similarities, is we know that pesticides can affect them in similar ways. So one of the ways some pesticides work, not all of them, is they disrupt the chloroplast. So they stop it producing plant energy, or chlorophyll. Interestingly, they tend to do a similar thing in human mitochondria, and they disrupt the mitochondria and prevent us from producing ATP. So there's experimental work on this. I've just got one of many studies here, in case you don't believe me. But they looked at a common pesticide called atrazine, herbicide, and basically they found here, after exposure of mitochondria to the atrazine, that they became swollen, malformed, they weren't producing energy, the basal metabolic rate of them declined. There was an increased body weight in the mice that were exposed to this, increased fat, insulin resistance, their appetite was changing, it just disrupted their metabolism, decreased energy, affecting the mitochondria and contributing to at least weight gain in this case. Interesting. So some take-homes around diet here are that, firstly, we really need to, if we're going to really fundamentally work on diet to help people improve their metabolism and lift fatigue, is just work on the overall healthfulness of their diet. I know it sounds boring. I'm not talking about paleo diets or anything. It's like we just need to eat healthy, more vegetables, less rubbish, pesticides, herbicides, additives, emulsifiers. Get those out of there and get all the good stuff back in, basically. Then from there, increasing phytonutrient density is a really important theme we've just explored, as these phytonutrients found in plants, tea, brassica vegetables, berries, this kind of thing, they have functional benefits that change our metabolism and could help improve physiological function that collectively will help fatigue. Getting sugar out of there is really important, and a simple construct we can use is just lowering the total glycemic load of our diet. The majority of sugar that we're eating, and the average person in the UK, the average adult is consuming about 14 to 15 teaspoons of refined sugar a day. They're not adding that to anything, it's in refined foods. It's added, or what we call hidden sugars. So getting away from processed foods is a good start, but then also working with this concept of lower glycemic load is a good idea. You can also look at caloric reduction. I hate the term caloric restriction and reduction. It sounds stressful to me, so I like to use the term food rest. So have a rest. Don't snack all the time if you don't need to. Skip breakfast if you don't feel like it. And guess what? That's caloric restriction and intermittent fasting. It's like being a bit more intuitive and not thinking that you have to eat all the time. For a lot of people, especially if you're chronically ill, it's a good idea to work with a nutritional therapist around this so they can construct a sensible food plan and guide you through this with a lot of coaching, because it's always a lot easier said than done. And then, of course, eating organic is really key. And I think if you don't do it for yourself, do it for the farmers that might develop chronic fatigue because they're using all these pesticides. But certainly do it for the environment. So moving from here, I want to touch on a few things around nutrition, and we'll step through these. The first thing I want to state, and you'll see this as a reoccurring thing with me, is just we can't overstate the effects of these. Often the studies we're looking at are small numbers, the effects are modest. I'm not saying any nutrient cures anything. In fact, Roger Williams, who's accredited with discovering a number of the B vitamins, but also accredited with developing the idea of biochemical individuality, quite famously, so really a pioneer of early personalized medicine, said quite rightly is that while no nutrient by itself is an effective remedy for any common disease, nutrients acting together quite likely will be a remedy for many diseases. There's a lot of truth in this. But we are going to look at them individually, because that's how we look at things, through a reductionist lens. And I'm going to start talking about a couple. The first being CoQ10. So CoQ10 is not really a traditional nutrient. You don't really get appreciable levels from your diet, but your body makes it. You do get small amounts from your diet. So it's more, I don't even know what you exactly call it, but we consider it a kind of nutrient. It's been well studied in the area of chronic fatigue, fibromyalgia, and fatigue in general for many years, because CoQ10 is a cofactor, or a substance that's involved in mitochondrial energy restoration and production. So it plays a really fundamental role there. Now there's been quite a lot of work, including studies like this by the legendary Dr. Michael Mays, looking at CoQ10 status in chronic fatigue patients. They've been exploring this for several years, and have demonstrated, as other groups independently, that when you measure CoQ10 in the serum of people with CFS, it's low, or chronic fatigue, it's low. And then we need to ask, well, what happens when you supplement patients with chronic fatigue with a bit of CoQ10 to try and get these blood levels back up again? Their blood levels increase, their mitochondrial function improves, their energy production improves, their clinical symptoms start to improve, and start to dissipate significantly. Now there's a few groups that have been looking at this, but the most prolific was this group here from the University of, oh man, I've forgotten, but they're based in Spain, Cordero and colleagues. And what they've been looking at, because they've got this awesome equipment that we can't use clinically, looking at mitochondrial function and structure, and what they've been able to demonstrate is that by supplementing with CoQ10, you can improve the membrane structure of the mitochondria, you can improve the function of the electron transport train, reduce oxidative stress, and this translates to clinical benefits, particularly in fatigue, but they've also seen interesting correlations with improvements in mood and muscle pain as well. Now, most of their work is focused on fibromyalgia type syndrome, so I've included a reference on that here for you because there is often overlap between chronic fatigue and fibromyalgia. But importantly, I want to touch on one aspect of their work because it's clinically relevant, and that is the dose. They use 100 milligrams 3 times daily taken with food. The reason for that is because it'll raise your blood levels more significantly through the day. It needs to be taken in divided doses. Also, we know that doses under 300 milligrams don't tend to do much for fatigue. And we also know that taking it with food increases the absorption quite significantly. It's a fat-soluble nutrient, so you should just take it with some food because you're always eating a bit of fat, I hope. And yeah, that's important to understand. Unfortunately, CoQ10 is very expensive, but we'll come back to that. There are ways to personalize or understand whether or not an individual needs it. You can run a relatively inexpensive blood test to determine whether or not you should try it, or you could just try it, up to you. Another group of nutrients that are really important for improving mitochondrial function, the B group vitamins. So the B group vitamins are quite unique as a family of vitamins in that they collectively play a role in energy production and synthesis. So we have known again for years that patients with chronic fatigue syndrome tend to have deficiencies in B group vitamins as well as their metabolites and biomarkers when compared to healthier controls. We also know that the B group vitamins play a really important role in energy synthesis. So here's a B vitamin, here's a B vitamin metabolite, here's a bunch of them, there's another one, there's 4 more, there's another one, there's another one. So you can see they're sort of dotted through this pathway of energy synthesis. There's a few other nutrients, CoQ10, iron, that are relevant, and carnitine we'll come to in a moment there. But the B vitamins are really central to energy synthesis. They're catalysts that are involved in energy production. There have been several studies like this where simple B complexes, I think it's one of the biggest bang for your buck natural medicines you can get is just like a good multi or a B complex. Cheap as chips comparatively, works a treat, and everyone needs them. So what happens when you give someone a B complex? They feel better. Reproducibly, every study pretty much that's investigated a B complex has found that. Is that within 30 days of someone taking a B complex compared to placebo, their mood improves, their energy improves, and they just generally feel better. So this is one such study. They were just healthy individuals. This is a group of patients with chronic fatigue. So this was done in Slovenia a few years ago, this report. Brilliant little study. They just used a simple multivitamin complex rich in B vitamins. That was one of the main features of this particular formula. And you can see here in these women, they had chronic fatigue syndrome fitting the criteria. 2 months, a significant improvement in oxidative stress in their blood had gone down, their fatigue had gone down, they were sleeping a bit better, their nervous system symptoms were improving, headaches were going, and their subjective feelings of infection, like the swollen glands and the infection was reducing as well. Importantly, when you're using B vitamins, as Dr. David Kennedy beautifully put it in this, one of my favorite reviews of 2006. I feel like a radio presenter or something. My favorite review, it should be like a hot list every year. But this was absolutely phenomenal, and he points out rightly is that in all the studies we see on B vitamins, it's doses well above the RDA that work. We've known this since the 1940s, based on Abraham Hoffa's work and his colleagues, but we're coming back to that simple truth, is that the NRV or the RDA is probably too low for most people. For most vitamins, especially B vitamins. Another nutrient that's been utilized widely in chronic fatigue, mostly empirically, is vitamin C. Empirically, meaning there's not a lot of good research on it, unfortunately, but we do know that blood vitamin C levels are typically very low in patients with chronic fatigue syndrome. We also know that high-dose vitamin C can relieve fatigue. In fact, it was Abraham Hoffa's journal in 2008. This group from Japan published this study showing that a good 6-gram dose will lift fatigue quite significantly in very fatigued workers in this case. And it was Ron Hanahaki, who was a good friend of Abraham Hoffa's, who published this. A great guy. He runs a clinic in the States focusing mostly on palliative cancer type care, and they do probably more IV vitamin C than any clinic I've ever heard of. And what they did with their chronic fatigue patients with high Epstein-Barr antibody titers is they did a bit of a retrospective study on their high-dose vitamin C and the effect on Epstein-Barr antibodies, and guess what? The antibodies were coming down. Now, this is great because it adds a little bit of evidence to vitamin C. When I had chronic fatigue, my Epstein-Barr bodies were quite high. I was told there's nothing you can do about that, basically. So vitamin C might be one potential option as we develop that idea. And then another option for fatigue in terms of nutrients is carnitine. Again, we've known for many years that the blood levels of carnitine, this is an amino acid in patients with CFS, is quite low. It's quite reproducible across multiple studies. We also know that carnitine helps people. Again, this has been done in a small handful of studies, but multiple studies have found that supplementing with carnitine, like this early one here in 1997, 3 grams a day of L-carnitine, and people are getting better, basically. Their fatigue is lifting. The same was looked at for another form of carnitine. This is my preferred supplement, I guess, is the acetyl L-carnitine. Slightly different form, works better in the brain to help with fatigue. And quite a lot of studies on acetyl L-carnitine in fatigue in general, like this one. This is not in chronic fatigue patients, it's in older age individuals with severe fatigue, but you can see the effects here on physical function, mental function, and cognitive function improves as well. It sort of lifts that cloud a bit. Another nutrient, I think this is the last one of the string of nutrients we'll talk about, is magnesium. No, we've got fatty acids last. But magnesium, again, low blood levels have been documented many years ago. This is the Lancet back in 1991. Subsequent to that, a doctor by the name of Guy Abraham started testing the effects of magnesium complex with malic acid. It's just an organic acid. He used that because it's involved in Krebs cycle or metabolism in the mitochondria. So just giving a simple organic acid, you get loads of it in apple cider vinegar actually, or apples. And yeah, with the magnesium they found this, you know, in these small studies was working quite well for these patients in terms of fatigue, especially muscle pain. More recently, this study was conducted in a group a bit more rigorous, a bit more recent, in a group of women with fibromyalgia and associated fatigue, and you can see here improvements in fibromyalgia-associated pain and other symptoms, including depression. So there's something to this magnesium. It's certainly incredibly cheap, safe, and worth trialing in individuals. There are a few different forms of magnesium out there. I really think any arguments around absorption are defunct. I don't think that's an important factor to consider. What I feel is important is the substance that magnesium is bound to, because it gives you a sort of an additional function, really. So if it's bound to a bit of glycine, we know glycine can enhance blood levels of glutathione. This has been demonstrated in humans, and we also know it enhances sleep and also has a mild anxiolytic type effect as well. It's been used, for example, in patients with schizophrenia as a therapy. So I like it as a sort of nervous system relaxant. Citric acid, if there are more fibromyalgia, muscle pain type symptoms, for the citrate, which is a Krebs cycle intermediate. So it's just, I don't know, just my ideas. But certainly, again, citric acid alone, if you just give powdered citric acid, that's been shown to lift fatigue. There are clinical studies on that. So there's something to it, it's not just an idea. Now finally, I want to touch on omega-3 fatty acids. This is really interesting. We know that patients with chronic fatigue syndrome are low in omega-3, and that this deficit in omega-3 correlates with aberrations in their immune system. It was Michael Maser's group again that were first to look at this. And then subsequent to this, Bassan Puri and some of his colleagues started doing this remarkable work on high-dose omega-3 fatty acids in patients with chronic fatigue, and looking at its effects not only on the fatigue, but really interestingly on brain structure and function. So they were doing like MRI type studies at the same time. We've known for some time in patients with any sort of severe debilitating disease, you see structural and brain changes. I'm not saying CFS or ME is all in the brain, but we know the brain is involved. In particular, you see atrophy in certain regions of the brain. That's not a death sentence. We know the brain is plastic and it can grow back. One of the things that helps it do that is essential fatty acids. This has been demonstrated in multiple studies for years. So if you've been rigorously taking omega-3 fatty acids for years, you can pat yourself on the back because your brain is measurably bigger. But getting back to the topic at hand, patients with chronic fatigue who were given omega-3 fatty acids tended to benefit in terms of brain structure. I'll come back to that. Another reason we think that these essential fatty acids are working is that they are antiviral and antimicrobial, and they also improve mitochondrial function. So they sort of tick a lot of boxes for chronic fatigue. What happens if you give patients with fatty acids chronic fatigue? Well, it was David Horobin, the late great David Horobin, one of my heroes, who was first involved in, as far as I know, the first study of omega-3 fatty acids in patients with CFS. They used relatively, well actually I'm not sure we even call that a high dose these days, but they called it a high dose back then. And what they found was significant improvements in clinical symptoms. Since then, this has been confirmed by Bassan Puri's clinical work, again seeing improvements in clinical symptoms. And interestingly, he's also demonstrated in some of his studies that it's in fact improving brain structure and function as well. So in this particular case report, the individual came in a wheelchair, and it sounds like I'm blowing this all out of proportion, I'm just relating a case study. Came in a wheelchair, couldn't walk to the MRI machine when they came into the practice. When they came back several months later, after the fatty acid therapy, 6 to 8 weeks later, after high-dose EPA, they came back in and were able to walk a significant distance compared to before to the MRI. But the real proof in the pudding is in the MRI. Their brain scan significantly changed with increasing volume in some of these key regions of the brain that we're studying. So a question we need to ask is, well, and this is a common question I get a lot as a sort of around nutrition, is how much omega-3 should we take? So I sort of base it on two things. One of them is what we call the omega-3 index. It's a very simple spot test you can do that measures your blood omega-3 levels. It's quite well validated, and it gives us a bit of a reference range for where we should be. Most adults should be over 4. And then we have dose response studies now, which is great thanks to Robert McNamara and some other people that have been involved in this work. As we know that if you give 1 to 2 grams a day, it'll push most people above 4 and sit just above there. So we know that 1 to 2 grams a day for most people is enough to get you into quite a healthy range. There are instances where you may want to go higher than that, but as a general rule of thumb, 1 to 2 grams a day. That translates to a few meals of oily fish a week, so it's sort of in line with public health recommendations, but also you can achieve it with supplements if necessary, quite easily. So I have put a few basic products or supplement type recommendations here, a few clinical tips, and then a few guidelines on doses just to summarize this section for you. So here we have CoQ10, here you have plasma reference ranges or reasons why you might use it, then the suggested dose as a summary. There we have multi-B complex vitamin C info. It's more there for a reference, I don't want to spend time on this. Carnitine, magnesium, again, you see the theme there. So what I want to do is sort of move towards a close with taking this right out of nutrition, basically. And what I want to point out is that really we're just scratching the surface here. We're talking about the nutritional, the basic nutritional element of chronic fatigue syndrome. There's a lot more to this picture, including exploring and managing mitochondrial dysfunction, perhaps more comprehensively, also exploring and managing what we call HPA axis dysfunction. So that's the hypothalamic pituitary adrenal axis. Very simply, it's the stress response. And this, I guess you could say, along with mitochondrial dysfunction, is perhaps the most reproducible physiological finding in patients with CFS, is the HPA axis is malfunctioning, I guess you could say. But again, there's hope. It's not a death sentence. We've seen interventions that can improve that significantly, including in patients with CFS. Also, there's this issue of environmental toxicity, which is almost a day into it, well, a lot more into itself, but it requires a lot more exploration, and there are interventions that we can utilize to help address that if there is suspected environmental toxicity. There's also this deep issue of gastrointestinal health and dysfunction, which needs to be considered, as well as aspects of immune function and oxidative and inflammatory stress. So really, what we're starting to talk about and what we're moving towards right now is not any sort of prescriptive approach. It's a very personalized approach that's really aimed at exploring what's going on to the individual. And this is a beautiful quote from David Sackett. I'm probably taking it completely out of context, but the point I feel is quite relevant, and that is that without clinical expertise, the evidence is nothing. Is that we can look through all this, clinical trials, etc., and sort of blanket recommendations we've gone through, but it's really about the therapeutic relationship with the individual, helping explore with them their physiology, understanding what's going on, and then personalizing care. So to help do that, within the paper I've written, I've got this reference, but here I've just summarized it for you. I've got some of the key clinical investigations. These are largely pathological investigations through laboratory testing that we can use, including assessing nutritional status, as well as things like gluten sensitivity should be assessed for, and also food sensitivities. I feel both of these can play a really important role in the experience of fatigue for some people. Sometimes it could be the key thing. Certainly, we need to be looking at the function of the nervous system in individual as well, and there are a few basic assessments we can use, like a salivary or a diurnal, a waking or a diurnal cortisol rhythm to assess that. Environmental toxicity is a bit trickier, but there are ways to help assess that, both clinically through questionnaires and case taking, but also there are some ways we can do that with pathology testing. Gastrointestinal function is really key also, and there are some basic sort of blanket tests we can start with, like comprehensive digestive stool analysis to assess the overall function of the gut, which is a great place to start, and then we can get more specific, looking at things we call like small intestinal bacterial overgrowth, which we think may play a role for some patients, and also intestinal permeability, another factor. Chronic viral infections should be assessed as a routine of care. It's part of the NICE guidelines for the management and diagnosis of chronic fatigue. So these should have really been done if a patient's coming into you with chronic fatigue or has it. But certainly, if not, they can be called on. Oxidative stress and also inflammation here would be critical as well. The reason for that is because we know they play a really fundamental role in the pathophysiology of CFS and seem to be contributing to symptoms. Certainly there are interventions working on these that tend to suggest that targeting them could be beneficial. The other thing is, especially in the case of the inflammatory response, is that there is some evidence to suggest that people with chronic fatigue syndrome have a heightened risk for cardiovascular disease. It's not the strongest evidence in the world, but it's there. And it's also not surprising. If you are in a state physiologically of heightened oxidative and inflammatory stress, you're going to have a high cardiovascular risk. So one of the sort of collateral benefits of assessing these things is you're also assessing cardiovascular risk biomarkers, quite robust ones in the case of HSCRP, that could help manage cardiovascular risk or target that. And then finally, there's this issue of mitochondrial dysfunction. I think the safest thing to do, and this doesn't sound scientific, is just assume that it's there. We don't have good tests for this, unfortunately. There are a few around, but they're inaccessible to us. The best that we have to go on is urinary organic acids, which is not great. And we also have serum CoQ10, which is okay, but again, not a really direct biomarker. So sadly, there isn't a really good test to assess mitochondrial dysfunction for us clinically. It's in the realms of experimental research, but I'm sure that'll change one day. I was speaking to, I have a little podcast, and I interviewed a guy who wrote a book on mitochondrial medicine recently, Ray Griffiths, and he had a great phrase. He said, is that we should sort of triangulate mitochondrial dysfunction, meaning that we need to be looking at multiple things that point collectively to that. And it makes sense. You know, I was chatting to the manager of the Optimal Health Clinic recently. It's a clinic that specializes in fatigue, and they said that's exactly what they do, is they're looking at multiple biomarkers to try and pinpoint what's going on there. So what are they looking at? Inflammation, oxidative stress, magnesium, CoQ10, you kind of, and it just goes on and on. But it's multiple things that sort of, all roads lead to Rome. So I'll wrap this up very briefly with a quick case study to bring this home for you. This is published, you'll like, in the Journal of Chiropractic Medicine. And a beautiful little case looking at a 34-year-old woman with complaints of fatigue over a period of 2 years. She came into the physician. She had high serum thyroglobulin antibodies, low serum D3, low saliva DHEA, as well as a low saliva total and diurnal cortisol. What is that telling us? Nutrient deficiencies, immune reactivity, and her nervous system is shot. That's the plain language summary. She was moved onto a minimally processed, he called it an ancestral diet, but it's a minimally processed anti-inflammatory type approach, which will also be hypoallergenic by its very nature, and also personalised treatment based on the functional laboratory test. So I've got is sort of recommendations here, but very simply, the diet is super clean, super healthy diet, high dose multivitamin, hit with vitamin C, EFAs, a bit of vitamin D to improve their immunity, and then a little bit of support for this nervous system, a little bit of, in this case, using a little bit of DHEA and some licorice root extract. But that's it. And after 12 weeks, there was significant improvements in fatigue. I mean, this is a pretty picturesque, pristine, ideal, utopian case. It doesn't always work like this, and I don't want to give you false hope. But it does sometimes, and certainly I don't doubt its credibility. After 12 weeks of application of this approach, there were significant reductions in fatigue, and also there were follow-ups done on the blood work. So you can see vitamin D going up to a nice level there, the autoantibodies are dropping, the cortisol's improving, the DHEA is improving as well. You know, it's all getting better, so the lab results are there. We've also got the salivary cortisol analysis here. So here you've got the patient at baseline, so they're really low. They should be between these two lines here. And here at follow-up, they're starting to sit nicely within the healthy reference range. So we're seeing an improvement in their hypothalamic pituitary adrenal axis function and their cortisol rhythm, which is going to be helping a lot with their immune system, fatigue, and well-being. So a simple case, but it beautifully brings us home to where this is all at. It's about assessing an individual, starting with basics, optimizing their nutrition, and personalizing care in a way that's targeted, individualized, and takes into account the individual. Because as Jeff Bland has beautifully put it for many years, is that what we're talking about is moving away from this old idea of labeling an illness and prescribing a prescriptive treatment to really understanding function for an individual, because that's the way forward. We are, after all different. Thank you.